Hi guys, this is Mr. Urrego, and today we're solving absolute value inequalities. Absolute value inequalities, we're going to have two types. One, when we have the absolute value that is less than, when the absolute value is less than the number, then it's going to behave as an AND inequality. Okay? And when we have greater than, it's going to behave as an OR inequality. Let's start from this one. When is less than, what's going to happen is the following. I'm going to bring that inequality down. Okay? Which is x is less than 4, and what is going to happen in the other side, I'm going to copy the same symbol and I'm going to change the sign. Instead of 4, it's going to be a negative 4. Okay, that's one way of writing it. What's the other way? X is less than 4 and x, I change the sign, flip the sign, change the sign. Okay, and this is the same thing. Okay, it's the same thing. Now, this is an easier way. Why? Because we keep it under one compound inequality. Now, when we're solving this inequality, basically, we need to leave the x by itself. When the x is by itself, now we want to graph. All right? So the values are negative 4 and 4. Negative 4 and positive 4. All right? So we have two inequalities. We need to graph one at a time. So x is greater than negative 4. We go to negative 4. We put an open circle. It stays as an open circle. Why? Because there's no equal underneath. And now I'm going to read x is greater than negative 4. Greater goes to the right. So technically, what's happening here is it goes to the right. Now let's take the other inequality. X is less than 4. We go to 4. And technically, I'm going to put underneath. X is less than 4. 4 less. Okay? Because this is an inequality. This is less than or equal to 4. What's going to happen is I need the intersection of those two answers. Intersection of the two answers. So basically, I need the intersection of the two graphs. If you notice, in this piece, from here to the left, there's only one graph. In between the two numbers, I have two graphs. So this is the intersection. And from here to the right, I only have one graph. So and intersection. So it's between these two values, therefore my answer is in between the two values. Okay? How do we know? How do we check? You can grab any value and bring it back to the inequality. So anything between negative 4 and 4. You can have 0, for example. 0 should be an answer. 0, absolute value of 0 is 0, which is less than 4. Let's try another one. 1. 1 is in between, right? So 1, absolute value of 1 is 1, which is less than 4. Let's take a negative number. Negative 2 is part of the range, right? Every single value here is the answer to this inequality. Negative 2, absolute value negative 2, positive 2. Remember, when we do an absolute value negative 2 becomes a positive value. Why? Because it's a distance. All right, so negative 2, absolute value negative 2 is 2. And 2 is less than 4. So remember, and intersection between the two graphs, which is basically between the two values. In our case, negative 4 and 4 are not part of the answers because I don't have an equal sign. Let's try another one. Now we have the absolute value of 1 minus 4x, which is less than or equal to 5. Again, is an AND, right? Because it's less than, my absolute value is less than my number. Therefore, this is going to stay in the middle. So 1 minus 4x is less than or equal to 5. The symbol to the other side, change the sign, turns into negative 5. And now I'm going to solve for x. Because my x is in between the two symbols, whatever I do in the middle. So here we go. I got two symbols, two inequality symbols. So I have a middle section, a right section, and a left section. Whatever I do in the middle, I do in the right, I do in the left. Be careful. Normally we make mistakes because we don't do it on every single side. So let's go. Now, to leave the x by itself, I gotta cancel this. So minus 1 on the middle, on the right side, on the left side. So I have negative 6, this cancels, is less than negative 4x, which is less than or equal to 4. Leave the x by itself, divide by negative 4. Negative 4, negative 4. Okay? Now what happens? When I divide or multiply by a negative number, If I'm dividing by negative number, my inequality symbols will change direction, will flip. So instead of less than, this is going to turn into greater than. And both inequality symbols will change. Keep that in mind. And remember, divide the middle, right and left. Negative 6 divided by 4, negative 4, those two negatives become into positive. Reduce, divided by 2 becomes into 3, divided by 2 it becomes into 2. Negative 4 divided by negative 4 cancels out, and I have x, and here 4 divided by negative 4 becomes negative 1. Okay, now the x is by itself. I need to graph now. Okay, so, but keep in mind, every time I'm doing an inequality, I want to have my lowest number on the left side and my biggest number on the right side. Is negative 1 greater than 3 over 2? No, it's not. Therefore, I got to flip this. I got to reorganize. Negative 1 should be on the left side, and 3 over 2 should be on the right side. X is in the middle, okay? Because I'm changing the order, I got to flip the direction of the inequality symbols. And I'll double check. X is less than or equal to 3 over 2. X is less than or equal to 3 over 2. That's good. X is greater than or equal to negative 1. X is greater than or equal to negative 1. So this is the same as the previous one, but it's in order. It's organized. Okay? Let's graph. So my number line, I put a negative 1 here and 3 over 2 there, right? Because I have an equal. Every single circle, I have an equal underneath, so it's going to be shaded. It's included. And we said that because it's in between the two values, it's in between the two values. Let's double check real quick with one value. In between negative 1 and 3 over 2, I can say that this is a 1 or a 0 or 1. Okay, my original inequality. We got it back. All right, so let's plug this in. 0. 4 times 0 is 0, so 1 minus 0 is 1. Absolute value 1 is 1. Is less than or equal to 5? Yes. 1. Negative 4 times 1 is negative 4. 1 minus 4 is negative 3. Absolute value of negative 3, positive 3, which is less than or equal to 5. So as you notice, I check a couple of values and they satisfy the inequality. Now, let's do one step ahead. Every time we're doing inequalities, we normally solve, which we did, graph, but we need the interval notation. Interval notation. So once I have the graph, interval is simple. My graph is between between negative 1 and 3 over 2. That's my interval. So what I need to define is how it's going to be on both sides. If it's going to be parenthesis or a bracket. Because it's included, I put a bracket, or a square bracket, or a square parenthesis that people call it. Because it's included, square parenthesis or bracket. Okay, and that's my interval notation. Okay, so now we have this problem. We have absolute value of 3x plus 1 is less than negative 2. Okay, let's think about it. Is there any number that I can replace the x by that when I solve this and I do the absolute value, it will be a less than negative number? No, because the absolute value of whatever I put in here is going to be a positive number. Let's pretend that my answer was negative 4 at the end. Absolute value of negative 4 is positive 4, which is not less than negative 2. So in general, you need to understand that when we have this, we can have an absolute value less than a negative number. So there's no solution here. Let's pretend we didn't see that. Let's pretend that this is all right. So this is a less than, so therefore we have to solve it. So let's solve it. 3x plus 1 less than negative 2. The inequality symbol, same direction, change the sign. Okay? What we're going to do is we're going to solve it and see if it makes sense or not. Minus 1, minus 1, minus 1. This is going to give me 1 is less than 3x. Cancels, less than negative 3. Divided by 3, divided by 3. So I have 1/3 is less than x is less than negative 1. As you notice, the negative number is on the right side, so it does not make sense. So I got to flip this. So I have negative 1 is greater than x, which is 1/3. So let's graph this. So I have negative 1 over here, and I have 1/3 of it. Oh, 1/3 right there. Okay, let's graph one at a time. X is less than negative 1. Negative 1. Open because there's no equal. Less than to the left. The other side. X is greater than 1/3. 1/3, open, no equal, greater. Okay, so first of all, according to the inequality symbol, it doesn't make sense because normally we should be in the middle. And remember, and is the intersection of the two graphs. Is there any intersection in between this piece and that piece? No, there's nothing in common. Okay, so I have my original answer here. Let's try one of those values to see if it makes sense or not. So let's try, I don't know, this is -1, so let's try -2 for example. -2, 3 times -2 is -6, plus 1 is -5. Absolute value of -5, +5, which is not greater than -2, so it doesn't work. 1/3, something to the right, let's pretend 1. 3 times 1, 3, plus 1, 4, absolute value, 4, not less than -2. So as you can see, even though we made a mistake of solving and answering, that graph does not give me answers that satisfy the inequality. Therefore, this is a no solution. Okay? And I hope you understand that from the beginning, as soon as we see that, there's no number that when I do the absolute value will give me something that is less than a negative number. Never happened. So when you see a negative on a less than, it's not going to work out. All right? Let's work on the or now, which is greater. So now we have this. Absolute value of x is greater than or equal to 4. Okay? How do we solve this? It's the same principle as the other one. All right? We're going to keep this same inequality symbol. Okay? And what we do is we flip the symbol and we change the sign. So that's going to happen always. In my case, because it's greater than, it's going to be an or inequality. Okay? The idea is to take one at a time, solve it, and then when the x is by itself, you graph. X is by itself, x by itself. We graph now. We graph both inequalities on the same number line. Okay? Only one number line. Here we go. So let's take one at a time. So we have 4 and -4. This should be flipped, right? I need to bring the -4 here, and I need to bring the 4 there. Okay? So let's grab this one. X is greater than or equal to 4. I go to 4, circle. Because I have an equal underneath, then my circle is going to be a closed circle or shaded dot or a closed dot. Greater. X is greater than 4. To the right. Let's take the other one. X is less than or equal to -4. Closed dot or shaded or solid dot. X is less than -4. Less than is to the left side. Every time we have an or inequality, a greater than, my graph is going to point in the opposite directions. Okay? Let's double check if this makes sense in my absolute value inequality. -4, -5, -10, -20. Let's pretend that I have -5. Okay, something to the left. -5. Absolute value of -5 is +5. Is +5 greater than or equal to 4? Yes, it does. So this is making sense. Let's go to the right. Let's go, exaggerate. Something greater than 4, 10. 10. Absolute value of 10 is +10. Is 10 greater than 4? Yes. So you want to always double check. Now, we solve, we graph, interval notation. We have the graph. The easiest way how to get my interval notation is from my graph. What is the lowest value to the left? So my is -infinity. I'm sorry about that. It's like 8, but -infinity is the lowest value to the left. Let's write these values in between so I don't make mistakes. So to the left, my arrow is pointing to the left. The smallest value all the way to the left will be -infinity. My arrow is pointing to the right. What's the biggest value to the right? +infinity. Okay? So my interval notation, I can get it right there. Right there. What's my interval notation here? Starts on -infinity, comes all the way to -4. By the way, every time I do infinity, I'm going to have a parenthesis. Okay? -infinity or +infinity. So let's go to the other side. I'm going to have a parenthesis next to it. In terms of this value, I go to -4. So my interval notation comes from -infinity to -4. -infinity to -4. My infinity will have a parenthesis. My -4, I go back. It's closed, it's solid. Therefore, it has a bracket or square parenthesis. Here on the other side, it starts from 4 because we're looking at the graph. It starts from 4 all the way to infinity. 4 to infinity, infinity has a parenthesis. What about the 4? It's closed, therefore it's a square bracket. What is in between them? Union. So every time I'm doing greater than, okay, which is an OR inequality, it's going to be a union of my two answers. Union, okay? The AND is intersection between the two answers. My OR is a union between the two answers. Let's do another one. So we have this. Absolute value of 2x minus 5 is greater than 3. Again, we bring always the same inequality, which is 2x minus 5 is greater than 3. And we bring the same thing. Something to be careful with. You will never change any signs that are inside the absolute value. A common mistake is that people say, oh, absolute value, that negative has to be positive. No. You always keep the same. Whatever's inside the absolute value, you bring it here and you bring it there. The first inequality is the same. The second inequality, you flip the symbol and you change the sign. Okay? And depending on this inequality symbol, you decide if it's an AND or an OR inequality. In this case, because it's greater than, it's going to be an OR inequality. Then we solve one at a time. We graph, interval notation, and we're done. So let's go. Plus 5 here, plus 5 there, and that's going to cancel out. And I have 2x is greater than 8. Divided by 2, x is greater than 4. And one inequality is by itself already. It's solved. Second one, plus 5, cancels. I have 2x is greater than 2. Divided by 2, my x is greater than 1. Okay? I made a mistake on the symbol. Here we go. Make a mistake in the symbol. This is less than, this is less than. Okay, and now the word OR, make sure you bring it back all the way down. Okay, so x is greater than 4 or x is less than 1. We graph. The smallest value should be on the left side. Remember, and this biggest value should be on the right side. So here I have 1 and here I have 4. All right, let's graph one at a time. X is greater than 4. Circle. X is greater to the right. Okay. Next one. X is less than 1. 1 less than. Now is an open circle because I have no equal underneath. Right? And now, as you can see, my graphs are pointing in opposite directions, which makes sense to an OR inequality, which is a greater than. Makes sense. Double check. Let's take a value, something that is less than 1. Let's say that here we're going to have a 0, right? 0, 2 times 0 is 0, minus 5 is negative 5. Absolute value of negative 5 is positive 5, which is greater than 3. Makes sense? So this makes sense. Something that is greater than 4. Exaggerate. 10. 2 times 10, 20, minus 5, 15. Absolute value, 15, which is greater than 3. Makes sense. So we need to double check always to make sure that our graph, our answers make sense to the absolute value. If they don't make sense, then either you check the math or it's a no-solution problem. Okay? This is the process in general. Let's do a special case so we understand what's going on. Okay, now we have this problem. In general, by the way, the other problems that we've done are kind of simple. They didn't have anything on the outside, nothing adding, subtracting, or multiplying. In general, we're going to have an absolute value and a bunch of stuff on the outside. It behaves the same way as an equation. Our goal always is to leave the absolute value by itself. And once it's by itself, then we apply the two inequality symbols. Okay? In general, it's always the same thing. So my inequality symbol has a negative 2 on the outside and it has a 4 on the outside. Pretend that this is an x, right? We need to leave that by itself. So therefore, cancel this. Minus 4, whatever we do one side, we do on the other side. That cancels, and I have negative 2, absolute of 2x plus 1 less than 4. Next, negative 2 is multiplying the absolute value, so I divide on both sides. What happens when I divide by a negative number? my inequality symbol flips, changes direction. These two cancels out, and I have 2x plus 1 is negative 2. Okay? Oh, negative number. No solution? No. Just keep going and double check your answer. We don't have an less than, right? We don't have an absolute value that is less than a negative number. Now it's a greater than. So maybe it works. Let's find out. So how do we solve this? The same thing. Remember, we bring this into two inequalities, and my first inequality is the same information. Nothing changes on the inside. Same symbol, same number. What's the second one? 2x plus 1. I flip and I change the sign. I flip and I change the sign. Okay? And we solve one at a time. So minus 1, I have 2x is greater than negative 3 divided by 2, x is greater than negative 3 over 2. Okay? Now let's work on the other one. Minus 1, I have 2x is less than 1 divided by 2, x is less than 1/2. Once the x's are by itself, it's time to graph. Okay, negative 3 over 2, 1/2, so negative 3 over 2 is going to be on the left side, and the 1/2 is going to be on the right side. Let's graph the first one. X is greater than negative 3 over 2. Interesting. So let's put underneath. Negative 3 over 2 greater. It goes all the way to the right. Interesting. So I just graphed this one. Let's graph the second one. X is less than 1/2. So I'm going to go to 1/2. Circle. X is less than. What happened now? Interesting. So remember, I have that, right? And I have this going all the way to the right, and I have this going all the way to the left. But again, or is union, right? Union, meaning both answers. So this answer, let me translate over here. This answer and this answer from here to the left, both answers are part of my answer. So in this case, if you notice, once I draw my circle to the right and then I draw my circle to the left, I'm covering those points. So in my case, all the number line, look, from here to the right and from here to the left, if I do union, I'm counting with everything. In that case, every single number will be a solution to this inequality. Let's see if it makes sense. So let's try something on the left. Let's try something on the left, something in the middle, and something on the right to see if it makes sense. Negative 3 over 2 is negative 1.5. So let's try like something like negative 4, negative 5. Let's try negative 5. Negative 5 times 2 is negative 10. Plus 1 is negative 9. Absolute value is positive 9. Times 2 is negative 18. Negative 18, right? 4 minus 18 is negative 14. Is negative 14 less than 8? Yes, it is. Between negative number and 1/2, let's try 0. 0 times 2 is gone. Plus 1 is 1. Absolute value 1 is 1. Negative 2 times 1 is negative 2. 4 minus 2 is 2. Is 2 less than 8? Yes. So this worked out, this worked out. Now 1/2, something greater. Let's keep it simple. 1. 2 times 1, 2. Plus 1, 3. Times 2, 6. So right now I have a negative 6. 4 minus 6 is negative 2. Is negative 2 less than 8? Yes, negative 2 is less than 8. Therefore, that worked out. So as you notice, I try a value in every single segment of my graph, and it worked out. That means the whole thing is part of my answer. Therefore, that's all real numbers. How do I write all real numbers as an integral notation? From negative infinity to positive infinity. That's how I write all real numbers. Always make sure that you double check the values from your graph in your regional inequality. Okay? All right, guys, that's it. Make sure to subscribe to the channel, like the video, comment, ask questions if you need to, and give me ideas for future topics. All right? Thank you for watching. I'll see you in the next one. Bye-bye.